All right. So I'm going to be talking about prisms and pyramids and cones and cylinders and about surface area and about the shapes and the bases and all that fun stuff. So we're just going to start with prisms. And prisms are 3D shapes that have two identical sides facing each other. And the identical shapes are the bases. So the bases can be triangles or squares or any other polygon. So in this case, this is a rectangular prism, and these two are the identical sides that face each other. That what Google said is the bases. So we'll say these are the bases. This is a tissue box, and this is a rectangular prism. You can see that has a lot of sides. Don't mind the hole, but it has a lot of sides. These sides are identical, these sides are identical, these sides are identical, and these would be the bases. So now we're gonna go to the pyramid that, I made out of paper because I couldn't find a pyramid, but this is a pyramid, and a pyramid is a structure with a square or triangular base. So on this pyramid, this will be the base, even though, it's hollow and it don't got a base, but if you just imagine, this would be the base. This is the square, and it would be the base. And it has sloping sides, which are these, that meet at the top. And this is the top. It meets to form a point. This is a pyramid. All right, so now to a cone. This is a cone, like ice cream cone, And a cone is a solid or hollow object, in this case it's hollow, that tapers from a circular base, this would be the base, a circular base to the top and forms a point. So this would be a cone. Now a cylinder, and a cylinder is a solid geometric figure with a straight parallel side. So, it's straight, it goes up and down, parallel sides, they're parallel, with a circular base. So these will be the base, even though they're hollow because it's a toilet paper roll. But if you just imagine there's a base, these would be the bases. So now I'm about to teach you how to find the surface area of a rectangular prism or this tissue box. So if we open up this, it's gonna show the net of this rectangular prism. So if we open this up, we would see this. Now with the regular box, it would probably be a lot more slots and sides, but figuratively, this would be the net of a rectangular prism. So I'm about to show you how to find the surface area of this. So just like thinking, this is not drawn to scale, but just thinking of this, you can see that there are a lot of different shapes, a lot of different rectangles and squares. And so what I would do to find the surface area is I would separate these into little sections. So these two will be the same, these two will be the same, and these two will be the same, because in the end they all have to connect to form one of these. So in order to figure this out, we know that the area of a rectangle is length times width. So if we start here, we see that the length of this rectangle is 2 and the width is 8. So 2 times 8, that's 16. So we put 16, and these two are the same. So we could say that this one is also equal to 16. So the area of these two rectangles will be 16. And then we move to another one like this one. And since in the end we have to create something like this, we can assume that this side and this side will be the same. Remember, these are not drawn to scale, so I know this don't look the same. But if you just imagine with me, these will be the same. So this will also be equal to 2 centimeters. So this 2 times the 5 will be 10. So the area of this would be 10. This is the same size, same shape, 10. Now with the last shape, this is 5. So we can assume that this side would also be 5 centimeters. So 5 times the width of 8 is 40. So we can say that this area is equal to 40. Area is equal to 40. In the end, we would add all these measurements up, and we would get the area of the, spill on my hand, we would get the surface area of this rectangular prism. All we have to do is add up all these measurements, and we would get the surface area. All right, so now we're going to talk about the area of a cylinder, or the area of this right here, this cylinder. So when you're looking at a cylinder, you would see the circle on the bottom, the base, the circle, and it goes up, and this side will be the height. So the equation to find the area of a cylinder, or the volume of a cylinder, would be area is equal to pi r, which is the radius squared, times height. So the radius would be like half of the diameter of the circle. So if you had the diameter and you need to find the radius, you would do the diameter divided by 2. That would get you to the radius. So for example, say we have this cylinder and the radius is 4 and the height is 5. In order to find it, we would plug it in. We would plug it into the formula, and we would do pi 4 squared times 5. And 4 squared is 16. So now we have pi 16 times 5. 5 times 16 is 80. So the area will equal to 80 pi. And if you want to simplify that, you can. Some people don't simplify it. But if you did want to simplify it, all you have to do is do 80 times pi, or 80 times 3.14. Anything that you would want to do. So area of a cylinder. All right. So lastly, and then this video will be over, we're going to talk about the area of a cone. So if you take a cylinder and a cone, and you put them together, you would get this figure. Now a cone, I know this is crazy, right? When I heard this, I was like, wow. But a cone is exactly 1/3 of a cylinder. It's 1/3 of a cylinder. 1/3 of a cylinder. So, as you can see, if we put this cone in this cylinder, this will take up 1/3 of the space of the cylinder. So, the area of a cone is almost exactly to the area, the volume. I keep saying volume. The volume of a cylinder. So the formula would be area is equal to pi r squared times height, like finding the volume of a cylinder, but we're going to multiply that by 1/3 in order to find the volume of the cone. So say for example, we have this cone right here, and again the radius would be 3 and the height would be 8. We would plug that in. We will say pi 8 squared times 3 times 1/3. That'll give us the cone. So after that, 8 squared is 64. Now we have pi 64 times 3 times 1/3. And then we will simplify that. We will say pi times 192 times 1/3, because 64 times 3 is 192. In the end, when we do 192 times 1/3, we get 64 pi. So that would be the volume of our cone. 64 pi. Again, if you want to simplify that, you could do 64 times pi, 64 times 3.14, and you would get the simplified version of 64 times pi. That's it. That's it. Hey, let's go, Stecky. I know you're watching.